This can start. Comments. Most of you after you really got higher grades, some of you didn't, but overall the class average rose. About common mistakes I saw when I was grading it. Problem 1. Actually, don't remember what that was like. It was something like y equals x to the x cubed plus like 2 to the sine x or something like that.
Sine x.
Or it's different versions would have different thing. I think one was a sine, one was a cosine. Most people who actually attempted this the right way got the right answer. When most people didn't get the right answer is either one common mistake. For most of the people who didn't get it, common mistake. It is a mistake, note it as a mistake. Is they use the power rule for x to the x cubed. Why can you not use the power rule for x to the x cubed? Because the power is not a constant, right? So that would, right? If you use power rule for x, I gave you 0, right? That's just not a mistake that you should be making. Another common mistake is they used, there's a rule that says dd of a to the u is u prime a to the u ln a, and they use that for this. I saw some people do that. That's also a mistake. Why can this rule not apply here?
The base is not.
Because the base is a constant. The base here is a variable, right? There's a reason why I make you copy the rules on quizzes. I want you to know the rules. Know when you have a formula that applies. This formula does not apply here because the formula has a constant base. You don't have a constant base. Power rule doesn't apply here because the power rule requires a constant power. You don't have a constant power, right? Be careful of the rules that you're applying.
The rule applies to the other one, right?
This rule could apply here, yes, because the base is a constant. Another common mistake I saw was someone decided to do log differentiation, but they decided to log both sides, and then they, well, more than someone, I think several people, maybe even a handful. They did this. What's wrong with that? Logs do not distribute across products, right? If you're going to log both sides, it would look like this. And log of a plus b is not the log of a plus the log of b. Logs do not distribute across sums, right? There is no rule that looks like that, right? A lot of people are mixing up the log rules. I also saw later on in the test, people had something like, I don't know, let's say 15 over ln of 3, and they thought of this as ln of 15 minus 3, and they wrote like ln of 12. An example. That is not correct. That is not a rule. What's the rule they were thinking of here? It's if you have ln of 15 over 3. What could you say about ln of 15 over 3? That's ln of 15 minus ln of 3. So you see here, there's only one log. You don't have a log of a top and a log of a bottom. It's log of a quotient, right? And then that log gets split into 2 logs where there's a sum. They used 1 log on this side and 2 logs on that side. Completely, they mixed up the rule, right? That's why on a quiz, I will ask you, what is this? Because you should know that you can't mix that up with this. It's not the same thing. It's not the same. We have a rule for this one, we don't have a rule for this one. If you see something like this, you leave it alone. Right? Some people try to apply a log rule. Be careful of your rules. There's a reason why I ask you, always copy down the rules. Do the rules on the test. What's the general formula for this? It shows up, right? Because people do all sorts of craziness because they don't really know the rules. They apply power rules when it doesn't apply. They apply this exponential rule, it doesn't apply. They try to log both sides, and they actually distribute the log across the sum. That's not a rule. It does not apply. What other... Well, of course, the normal things like people who drop signs and things like that. What else did I see that I should mention? Exponentials. Just so we're clear, if y is equal to something like e to the pi squared, what is y prime? 0. Why? It's a constant. How do I know it's a constant? E is a constant, pi is a constant, 2 is a constant. It has nothing but constants in it. There's no x. It's a constant. A lot of people try to do the exponential, they thought something like this. They somehow differentiated that and then put it here. No, it's a constant. What other common rule mistake did I see? Oh yeah, I had a few people commit blasphemies, so there's that. But beyond that, the L'Hopital's rule problem. I think, what was it, 0? E to the x minus 1 minus x, was it? Over x cubed.
4. X 4.
Well, there are several versions. Let's do x to the 4th, right? So you looked at this and you're like, okay, what does this actually approach?
0.
I plug in 0 here, e to the 0 is 1, so this approaches 1. Right? And then inside here will be 1 minus 0. The bottom is actually 0 to the 4. So this seems to approach 0 over 0, right? So you can apply L'Hopital's here. And many people did, and that's fine. What does the derivative of this look like? Derivative of the numerator? Plus 1, right? Because that negative sign distributes over 4x cubed. Right? Now, usually, unless you did something like left this symbol off, which is actually important for you to write, you would have gotten like 4 points for just doing that, right? But the meat and potatoes of the problem happened after that. What does this approach? This approaches 2 over 0. Now, there are a couple of things that can go wrong here. There's the really wrong when someone actually divides by 0 and tells me, oh, that's 0. Blasphemy, right? They actually divide by 0 and tell me that's 0. But let's pretend we're not that crazy. What would you do here? I'll tell you what a bunch of people did. They applied L'Hopital's rule again. And eventually they got to a half. Could you apply L'Hopital's rule again? Why not? It's not 0 over 0 or infinity over infinity. You do not have the form for L'Hopital's rule. Don't just rush in and apply rules without thinking. You can't do L'Hopital's rule here. It's not a 0 over 0, infinity over infinity, right? So if you made it up to here, you got 4 points, and whatever else you did, I just ignored it. Right? L'Hopital's doesn't apply here. How would you actually continue? How would you, if you see 2 over 0, and you know you're not going to do something crazy like tell me that's 0, how would you actually get to the answer?
Does that approach infinity? Because since
Does it?
it goes to 0, very close to 0, but very small number on the bottom, and you have 2 on top. So it doesn't go close to infinity. It's a large number.
It depends. I'll show you some examples of how you know it would depend. Look at these two guys. Let's say 2 over x squared and 2 over x. What's this limit? This is infinity. What's this limit? Does not exist. Do you see the issue that can happen?
I think in class we did it doesn't exist.
I did. I definitely did. It's on video. Why did this one not work out while this one I could say was infinity?
Because if the bottom, if the x is like a negative 0, 0, 1.
Right, you look at the right-hand limits. What if you're approaching 0 from the left and you're slightly negative, right? Your function looks like this. Meaning if you're approaching 0 from the left side, you're getting negative values. Approach 0 from the right side, you're getting positive values. The two limits don't match up. This guy, however, because this x is squared, you're getting positive values either way. So on both ends, on both sides, you're going to infinity. Over here, on one side you're going to negative infinity, on the other side you're going to positive infinity. Therefore the limit does not exist. Here the limit is infinity. So it's also not true to just automatically say that's infinity. I don't think I consider that a blasphemy if you did that, but I probably gave you 0 for that whole problem. But how you would approach this would be when you see something like that and you cannot simplify, you check both sided limits. You should have checked, what about x approaching 0 from the left of this function? Notice that the top is always positive because it's an exponential plus 1. What about the bottom though? X cubed, if x is negative, is what? Is negative. So I have a plus 2 over 0 but slightly negative. So this side gives me negative infinity. However, if I come from the right side, this again gives me a positive 2. However, now my x is slightly positive, so x cubed is also positive. So now I get 0 with a little positive charge. That gives me plus infinity. And then you are supposed to say, oh, I got a plus and a minus. So it does not exist was the answer to this limit. Right? So be careful of your rules is the moral of the story. There's a reason why I ask you to copy them down. There's a reason why I ask you to look at things carefully. There's a reason why every time I do a L'Hopital's rule problem, I ask you, what does it approach? 0 over 0, infinity over infinity. If it does not approach those, you cannot apply the rule. It's just illegal.
How come you got 0 if you put infinity?
Huh?
Shouldn't you have got 4 points for like what we did before? You said you give us a 0 if we put infinity.
No.
But we did the previous part, right? Where you said you would give us 4 points for that top part.
I said I'd give you 4 points if you didn't do anything crazy like leave this off. But doing something crazy would also include automatically
That's not too
assuming that's
crazy, though.
infinity. That is too crazy. It's crazy because of this. You have no idea what it's going to go to. You have to actually do this check, or you can't just say. So there's one of two ways things are going. You have to do a check, right? I mean, if you're an engineer building someone's house, they ask you, so is this house going to fall down on top of me and my children? Yes or no? You don't even check.
Nope.
Fine. Yeah, totally fine. And you just throw out the obvious answer that you feel like, well, you know, no other house I've ever built fell down, so, you know. No, you can't just end up in a crazy situation and just assume there's an answer, right? You have to be careful and you have to cover your bases. We are at... Yes.
So are we using the extended real number system then? So like if we had a limit approaching infinity, we could write infinity?
Only in regards to infinity being answers to limits, yes.
Yeah, so if the left and right hand side. But would it also be correct to write that limit as x approaches 0, 2 over x squared doesn't exist either because it's infinite, so there's still no...
Right, because we're using the extended reals. Infinity is an answer for limits. For limits.
Okay.
We take that convention. Not with anything else really though. Because there's arithmetic that goes with the extended real line that we don't apply. It's just limits. At this level, we only care about limits. Because we're more interested in how it talks about the behavior of a graph, right? If something is uniformly going up, we'd want to know as opposed to it splitting in two parts. Questions on homework 6.3? I think there was something else I want to mention, but I don't remember. The solution's already on the website, so. As well as if you got below a 70, not including the bonus points, you should talk to me. So just shoot me an email, try to set up an appointment, and should talk about, about stuff. Or if you want to talk to me otherwise, that's fine too. Just set up a meeting. Yeah, but it's mandatory to meet me and talk to me if you got below a 70, not including the bonus points. Okay, homework.
Integral of x cubed of the cube root of x squared plus over the cube root
Over the cube root
of x squared plus
x squared plus
1.
dx. This is 6.3?
Yep.
Okay, I feel like we learned how to deal with that already.
Yeah.
How would you do that? Right, I could do u equals x squared plus 1, or I can do u cubed equals x squared plus 1 to get rid of the cube, make it look nicer. So this means 3u squared du. I thought this was the partial fraction section, no?
It is.
What's this doing here?
Yeah.
Maybe it turns into a partial fraction afterwards, I don't know. Let's see. So I differentiate this would give me 2x dx, right? So now I have 3 over 2u squared du is equal to x dx. That's so far so good. I'm going to have to change an x squared here. I'm going to think of this x cubed as x squared times x. So I'm going to need to know what that x squared is, which is u cubed minus 1. And so now what does this integral become? Just start plugging things out. X squared, I'm just going to write u cubed minus 1. X dx becomes what? 3 over 2 times u squared du. And the bottom is just u. Yeah, I'm not sure why this is in that section. Okay, so this is just u to the 4th minus u. So this is u to the 5th over 5 minus u squared over 2. Yeah, some people forgot the plus c's. I only took off 1 point for that though. So u was actually the cube root of this, so this is actually x squared plus 1 to the 5 over 3. And this is x squared plus 1 to the 2 over 3. Okay. Yeah, I'm not sure why that's in this section. Okay, other questions?
31.
He had his hand up.
41, the integral of ln x squared minus x plus 2.
Ln of x squared was inside the ln like that?
Yeah.
Okay.
And minus x plus 2 all inside the ln.
This is all inside of it. Minus x plus 2 dx. Okay, how do we do that?
Use integration by parts. The question tells us.
It tells you to use integration by parts.
But
Really?
Yeah. You-
Let's say, do we know what this is? Good, love the response time. That's what I want it to be like all the time. See, I just said, what is this? X, you didn't even think about it, whoever said that. Just like, you just knew it. I love that. That's what it should be like, right? You know this, you don't need by parts. Let's just put that out there, right? Okay, with that said, how would you approach this?
you have x, you have u, ln u.
If I have u equals this, I'd have to worry about my du. Du would be 2x minus 1, which I don't have that anymore.
U equal ln x squared minus x plus 2 and then dv equal 1.
Okay.
You have to. A question there.
Oh, this is x squared minus x plus 2. That doesn't factor. Okay, I thought it factored. I thought there was a different sign. Okay, we might need that integration by parts. I thought that factored, in which case it would be stupid. Okay, so so at this point, there's nothing you can integrate, so you obviously do a derivative for this guy. Oh, now this is a nice problem. It looks like we're going to get a partial fractions as a result, right? We're definitely going to get some sort of crazy fraction. Let's see if we need a partial fractions after. So I don't know how to integrate that. And it doesn't factor, so I can't break it into two parts. But that might be a trick I might throw at you guys one day. Just so you know, I'm saying it. No one ever listens to me. Like that. If you saw that, what would you have done? Right, you could have factored this, which is x minus 2 times x plus 1, right? And then you do the log rule, which is ln of x minus 2 plus ln of x plus 1. And then you integrate separately, but we know the rule that we just did here will just tell you this is x minus 2, ln x minus 2 minus x minus 2 plus this guy would be x plus 1, ln x plus 1 minus x plus 1 plus c. I thought the sign was this, so yeah. So if it was something like that, it would look scary, but you'd actually it's actually not that bad. Okay, let's. All right, so dv would obviously just be dx. Let's see what happens. So du is what? 2x minus 1 over x squared minus x plus 2. V would be, so call this I. My integral now would be u times v minus the integral of vu. Right, so we have 2x squared minus x over x squared minus x plus 2. How do we deal with that?
Complete the square. Complete the square. Oh wait, divide first.
You can do long division. You could also do algebraic manipulation on that. It's not that bad, but let's go do the long division. So this is 2x squared minus x. X squared into this goes 2 times that. 2x squared, 2 times that, minus 2x, 2 times that, plus 4. Subtract that line, this dies. Minus x plus 2x gives me x minus 4, right? So this is just integral of 2 plus x minus 4 over x squared minus x plus 2. How do we deal with that guy?
You could do the so it's x over x squared minus x plus 2 and then minus 4 over x squared minus x plus 2. Separate them.
Yeah, you would separate them, but what do we have here? This would be x ln x squared minus x plus 2 minus, well, this would just be like 2x plus,
I think it should be times up and down 2
times what?
times 2 over 2.
Oh, yeah, where?
In s minus 1. Yeah.
In here? You want to multiply by 2 over 2? Yeah, we could do that.
Then you can use substitution.
Yep. We could do substitution before that even, and you will just have that 2 factored out. So either way it can work. So now we have this. So what did you do? You multiply by 2 over 2?
Yeah.
And so what would you split this up as?
Times integral 2x minus 8.
2x minus 8 over x squared minus x plus 2.
And the 8 becomes minus 1 and minus 7.
Yeah, split the 8 into minus 1, minus 7.
Then you separate 2x minus 1.
Then you separate. That's going to give you that u sub in 1. And the other one we're going to have to do something else. Since it doesn't factor, we'd probably have to do a complete in the square. So this is just the integral of, basically this is just going to be ln of x squared minus x plus 2 minus 7 over 2 times integral of 1 over x squared minus x plus 2. How do we deal with that guy? We're going to need a trig function, which means we're going to need to do what? Complete the square, which we're all experts at now. If I complete the square here, what does it look like? It's x minus a half, right? Which is going to give me a quarter on the outside. So I have to subtract a quarter, so it's 2 minus a quarter.
So
Plus
7 over 4.
7 over 4. And at this point, that's just going to be an arctangent, right? So finally, this is equal to x ln x squared minus x plus 2 minus 2x plus a half ln x squared minus x plus 2, which I don't need the absolute values because it's always positive, as you can see from the thing here, minus 7 over 2 times. So this is going to be not 4 over 7, 2 over radical 7, tan inverse of x minus a half. Right? I'm using the rule that says x squared plus a squared dx is equal to 1 over a tan inverse x over a. So my a in this case is radical 7 over 2. That's all in here. X over a. Or if you want, you can actually do the trig sub. X minus a half is equal to radical of 7 over 4 times tan theta. Go through all the stuff, do the back substitution with the triangles, do all that stuff. You'll eventually get here. Other questions? That one was rough. See, I'd be much nicer. I'd be the one. Mine only looks scary, but when you see the trick, it's like.
So this is like a one.
I don't think one this long would be on the final, no. Not that annoying problems aren't on the final, but this seems too heavy for a final problem. But it's good practice though. If you can do this, then it's like, the final problem is no big deal. Other questions? 33. Can I get rid of this?
The
I think we'll just spend the rest of the time doing problems, and we'll pick up on 6.5 next time. Which, just read through these. These are all the rules you need to know, and we're going to do these examples on the next page. So if you want to attempt them on your own, you can, and try to follow in class. But yeah, I'm not going to tell you much more than this. I mean, at this point, I don't think there's any point into deriving these for you or explaining what they're about. It's one of those things where you just memorize the formula and plug and chug, because it's not going to be any use to you any point later. It's one of those kind of useless topics. Basically, they expect you to be a computer. If you ever end up in a situation like that describes, you put it in a computer. There's literally no need for human involvement. But they want you to know what your computer is doing, I guess, in case you need to debug a program or something. Okay, so how do we deal with this?
I tried doing it the ax plus b and then cx plus d, but it got me nowhere.
Yeah.
It got you nowhere.
Because you get to the same point. And then I went to the tutoring center and the guy did
You get to the same point. Well, that's,
Trig sub complete the square. No, trig sub.
you did a trig sub and completed the square? But I'm curious as to where you end up, because that's what I would try. Like if I, approaching this for the first time, I try to do a partial fraction. So let's look at this guy. So let's see what problems happen now. So how would this split up?
ax plus b over square plus 2x plus
Okay, and so now we multiply both sides by the denominator, and we would have ax plus b times x squared plus 2x plus 4 plus just cx plus d. At this point, there's sort of no real convenient value. I'd probably just multiply out and equate coefficients and try to get the answer that way. What's this multiplied out?
ax cubed plus 2ax squared.
Right, just do one at a time, expanding. So we do ax cubed
plus 2ax
plus 2ax squared
plus 4ax
plus 4ax
plus bx squared
plus bx squared
plus 2bx
plus 2bx
plus 4b
plus 4b plus cx plus d. These problems are just like exercises in concentration. Like give monks these on the top of a mountain that's meditating to try to keep his balance while doing one of these. That would be awesome. Okay, group like terms.
So x cubed
There's only one x cubed, so ax cubed.
equals 0.
Right, you automatically know a equals 0. Let's finish grouping them though. Do we have x squares?
2a
I have 2a
plus b
plus b times the x squared.
Equals 2b.
4a plus 2b plus c.
4a plus 2b
Plus c.
for the x's.
And then d is just
4a, 2b, c,
d is equal to
and now we have 4b plus b, right? Answer to those. So now we know here we have 0x cubed plus 0x squared plus blah. And so now we see here that our a must be equal to 0 because the x cubes must match up. Which means this must be also equal to 0. But if my a is 0, my b has to be 0 as well. So that pretty much kills this guy. So yeah, we are going to get the same thing. right? We wouldn't have to do anything else. It's obvious that if this guy dies and this equals that, then my C has to be 1, my D has to be -3. So yeah, doing this gets us nowhere. Okay, so another approach. C would be 1, D equals -3. That's the odd time. I'll think about that and get back to you, because I feel like there should be a way that you'll realize that would happen before going through all this trouble. But right now I don't see it. Anyway, so knowing that that doesn't pan out, actually doing the partial fractions isn't going to get us anywhere. Now what do we try to do?
Complete the square.
Complete the square is the only thing we can do. What else can we do? So let's complete the square and see what happens on the inside. X plus 1 squared plus what? Plus 3. All squared. And how do we deal with that? Come again? I can do x plus 1, turn that 3 into a +1 and a -4. And then I can do a u equals x plus 1. My du would just be dx, sure, just to cut down on the writing. So this guy just becomes the integral of u minus 4 over u squared plus 3 squared du, which I can split up. So this is u over u squared plus 3 squared. So this guy is going to be what? Technically it's like another substitution, right? You can do something like t equals u squared plus 3, but what's going to happen at the end of the day? We're going to get 1/2 times what? We're going to get -1/2 times u squared plus 3 to the -1, right? Because if I differentiate that, I move that down, it becomes positive. This becomes a -2 power, which brings it on the bottom and squares it. The derivative of this is 2u. 2 is going to cancel with this 2, and I just have u. Minus, what do we do with this guy? Trig sub, right? It's hard to get out of it. We tried our best to get away from it, but we couldn't. So at this point, we're going to do a trig sub. What's the substitution? Radical 3 what? Tangent, because it's a plus sign. Okay, so my du is going to be radical 3 secant squared d theta. So ultimately this guy would become the integral of 4 du is 4 times radical 3 secant squared theta d theta over, this would be, under here would be 3 tangent squared, right? 3 secant squared. So what do I have here? 3 to the 4th secant to the 4th. Right? And how do we deal with that? So this cancels into that, goes a square. So this is -1/2 u squared plus 3. What now? How do I deal with 1 over secant squared?
Cosine squared.
It's cosine squared. So this is 4 radical 3 over 3 to the 4th times the integral of cosine squared. Come again?
Yeah, it's 3 to the 1/2 square.
3 squared.
Where are we talking about?
Where it's
Oh, this? Yes, squared. And that's to the 4th. Right.
Yeah.
So this is squared. Okay. How do we deal with cosine squared? Right, that's just 1/2 times 1 plus cosine 2 theta, right? So this half is going to cancel into that 4, so I'm going to have 2 radical 3 over 3 squared times theta plus what? Sine 2 theta
Over 2.
times 1/2 plus c. Okay, let's start back substituting. Let's figure out what our thetas are first, and then we back substitute for the u's and the thetas. Yeah, this is another problem that's too long to show up on a final, but you learn a lot of lessons by actually doing it. Like every little situation could show up on a final individually. So let's do the back substitution. Let's set up our triangle. What do we have here? Tangent is u over radical 3. Tangent is opposite over adjacent, which means on this side we're going to have radical u squared plus 3, which means sine, we know our theta is just going to be tan inverse of u over radical 3. Our sine 2 theta, well, our half sine 2 theta is actually just sine times cosine. Sine of this is opposite over hypotenuse. Cosine of this is adjacent over hypotenuse. So this is just radical 3u over u squared plus 3. Which is equal to, let's back substitute. What was our u? Radical 3, x plus 1 over x plus 1 squared plus 3. And now finally we can say what the original integral was. The original integral is minus 1/2. Our u is actually x plus 1. X plus 1 squared plus 3 to the minus 1 minus 2 radical 3 over 3 squared times our theta becomes tangent inverse x plus 1 over radical 3. And then this guy becomes that. And don't forget the plus c, because then you lose a point. These homework problems are way meaner than I am. My test looks easy. I have to like up my game now. Other questions? It's going to take another half an hour. Well, we're not going anywhere. I have nothing else to do, right? 31 is what?
Integral 1 over x times x squared.
Times?
X squared plus 1 parentheses. Squared. Yes.
Sure. That doesn't look so or maybe, I don't know. It could be horrible. So
I tried decomposing, so it's a over x plus bx plus c over x squared plus 4, and plus dx plus c over x squared plus 4.
okay, so let's look at this guy. We'll probably try something else first, but this is fine. So I have a over x plus bx plus c over x squared plus 4 plus bx plus e over x squared plus 4 squared. This means 1 is equal to a times x squared plus 4 squared plus bx plus c times x plus 4 x squared plus 4 plus bx plus b times x. Right? Any convenient values here? 0 would wipe these guys out and can solve 8. X equals 0 would give me 16a, right? And then that's 0, that's 0. So this means a is 1 over 16. Yeah. A is a fraction, the others are probably going to be fractions too. Anything else that's nice? Nope. So, what do we want to do? Plug in random values or expand and equate?
Use the like
It gets crazy either way.
That's right.
Okay, did anyone actually do it? What did you end up with?
1 equals ax to the 4
What?
Ax to the 4
plus
plus
8
bax squared plus 16.
Plus bax squared?
8a.
Yes.
It's 8.
Huh?
It's an 8.
Oh, sorry, 8ax squared
8ax squared
Plus
plus
16a.
16a plus bx to the 4. plus
like this. Plus bx, 16a
Yeah,
Yeah.
plus b times x.
plus bx to the 4.
They're separate values.
Separate,
They're separate
separate.
values.
Oh, okay. So this is coming in?
16a
Plus
plus
bx to the 4 plus 4bx squared. Plus
Oh, I
cx
thought you were
cubed
grouping them. Okay, cx cubed
plus 4cx plus bx squared plus dx.
Are we done? I thought you were going to group them for me, and now
Oh,
I'm
my bad.
You guys want me to do all the work around you. Okay, so let's group them. A plus b times x to the 4th gets rid of those guys. Cubes,
C, yes, C.
there's just a c. Did anyone else do this and can confirm that this is what it's supposed to be? Okay, squares,
A,
plus 4b plus d
A, plus D,
8a
plus
4
4b
B,
plus d
plus 4b
plus d.
D,
plus d. Is that it? X squared. X's,
EX,
4c plus e and the d was already there. And what else we have?
16a.
And that's it, right? Okay, so now what are our equations? A plus b must be what?
0.
C must be what?
0.
8a plus 4b plus d must be
0.
0 again. 4c plus e must also be 0. 16a. Well, we already actually knew what the a was, but that's okay. So this gives us no new information, but that does give us some information here, right? So this means that b is minus 1 over 16. This means a is 1 over 16.
E equals 0.
C equals 0, which also means that E equals 0. So we have those two. And what are we left with? We have A, B, C. I need D now. Which I know A and B, so let's figure that out. So 8 over 16, which is 1/2, minus 4 over 16, which is 1/4, plus D equals 0, which means D is equal to 1/4 minus 1/2, which is equal to minus 1/4. Right, so we have A, B, C, D. And so our original integral is the integral of A over X, so that's 1/16 over X. Is C also a minus? No, C is 0, but it's minus B. B is minus 1/16x over x squared plus 4. D is minus. Right, and at this point, this is a log. Substitution gets rid of those, right? So this is going to be 1/16 ln x. 1/32 times x squared plus 4 to the ln of x squared. 1/32 ln x squared plus 4.
Plus 1/8 x
And
squared
this
plus
is going to be
1/8 x squared plus 4.
1/8 x squared plus 4 to what power?
-1.
Right, that would be
It's plus 1/8.
where's the positive?
Plus 1/8.
Because it's to the -2 powers, so you have to multiply by -1.
Right, so this is I've been doing marathon, bro. We're good. Other questions? Okay, so how do we deal with that? You can factor it. Difference of cubes formula. In which case I'll do partial fractions on that. So 1 would be equal to a times x squared plus x plus 1 plus bx plus c times x minus 1. I can throw that x equals minus 1, x equals positive 1 to kill that. And so I would get 1 is equal to 3a. And so now, if I said x equals 0, what happens? 1 is equal to a minus c, right? Which means I have 1 equals a third minus c. In other words, c is equal to a third minus 1 equals minus 2/3, right? I just need one more value, so let's plug in something else. I tried 1 and 0, well, how about minus 1? So if I plug in minus 1, I just have a coming in. Right, that would just be a. This here, I'm plugging in a -1 for x. It's minus b plus c here, minus 2. So this is 1 is equal to a is a third. This would be plus 2b And this will be minus 2c, which is
4/3.
plus 4/3, because c is a negative. And so this means 2b is equal to, or b is equal to a half of 1 minus a third minus 4/3. Huh? It's negative 1/3 in the end? And so my original integral is the integral of a over x minus 1. My a is a third. B plus C over x squared plus x plus 1. What else do we have here? So the first one we know. The second one, we'd split that up. So I is equal to third ln x minus 1 plus, I can do minus 1/3. Let's take this out. And so this would be x plus 2 and how would I split this up? Plus 1 minus 1, would that work? The derivative of this would be 2x plus 1. There's a 2. I can multiply by 2 over 2 to make that easier to digest. That would be 4, this would be 6. And then I can split this up into 1 plus 3. And so I can break it into this part and that part. Right? And so this would be minus 1, 6. This part here would give us what? ln of x squared plus x plus 1 minus 1, 6 times this part is just going to be the integral of 3 over, how do I deal with this part? Because this doesn't factor, so I'm going to have to complete the square. It's going to be something like x plus a half all squared and plus 3 over 4. So I'm going to think of that as radical 3 over 2 all squared and apply my formula. So this 3 actually cancels into this 6. This is just a half times 1 over a, right? So this is 2 over radical 3 tan inverse of x over a plus c. And then after all that, your textbook might do some like combine these logs and then you okay, I still didn't get the answer. So check that if you only see one ln in the answer, just check that they didn't combine it. They would have also, of course, cancelled these 2's.
Nope. Nope.
They
All
didn't?
they did was the R10.
No.
Just got rid of the two denominators.
Do you have other questions?
Do you have an approximate date for our next exam?
So the next exam is we're gonna do 6.5, which probably should be quick. That will be maybe less than half a class we'll spend on that. And then 6.6 will probably be a full class. So today's Thursday. Tuesday, I will expect to finish 6.5, part of 6.6. Thursday, I should finish 6.6. So it'll probably be the Thursday after that. So, not next week Thursday, but the Thursday after. What date is that? Hmm?
I think it's November 6th. November 6th.
That's November 6th? That's cutting it close. Well, it depends. Is anyone here gonna drop? The last day to drop, I think, is like November. I think it's November 6th, if I'm not mistaken. Yeah, so, challenge accepted. Good. Okay, but we'll, like I said, we'll stop there. We have 10 minutes to go, but I don't want to start another one of these. Take like 40 minutes, because these questions you guys are asking are crazy. So we will stop there.